So, like many of you, I'm a pretty big geek, and as a result, I never leave home without an oscilloscope and logic analyzer and an ArbGen and wall clock. So, no, I'm just kidding. What I really just have is the oscilloscope watch. All right, so 10 years ago, when I was admittedly a little less full of engineering knowledge, I saw this on Kickstarter. Oscilloscope watch. It was an oscilloscope and an ArbGen and a logic analyzer. Could even play games. I thought that was so cool. I got to back that. So that was October 2013. Well, 10 years and 2 months passed by until this past December, December of 2023, this finally arrived in the mail. All right, let's take it for a little spin here. So obviously it has a watch mode that tells time, but if you look at the bottom, you can see this pin header, standard 100 thou, and they're labeled ground and 0 through 7. And then on the top, you see something kind of similar. You see, if you could read through the 3D printed case, channel 1, channel 2, ground, and some other things. So yes, indeed, this watch, the oscilloscope watch, that was again delivered 10 years after I ordered it, can in fact serve as an oscilloscope, a logic analyzer, and an ArbGen, albeit not great ones in any of those cases. But I'm getting ahead of myself. So let's hook up some signals to it. Right off the bat, you'll see one of the kind of drawbacks of this. In order to use it, you need to have some DuPont style jumpers with you. Now, it came with a bunch in the box, which was a nice touch. But let's be realistic. You're probably not going to be carrying these around in your pocket all that often. I suppose in a pinch you could probably jam a paper clip into the port or something, but let's get right on into it. So on the signal gen, I've got just a simple 1 kilohertz sine wave going in there. So let's see, how do we get in there? Yep, all right. So the UI is not exactly intuitive and it's highly modal. So bear with me as I kind of struggle through this, even though I've done this plenty already preparing for this review and also just playing around with it. All right, so we're in oscilloscope mode. We've got both channels hooked up. And now they're both actually on. There is an auto scale mode, so if you just hold down this button right here, you can see that, yep, we're seeing both signals. One's 90 degrees out of phase with the other, as the ArbGen is configured. And you see the vertical resolution, by default, looks pretty good. The problem, of course, is that you have the signals already biased upwards. That's a little bit annoying. Time base, easy enough to change that. No labels on these buttons. You just have to know or have read the manual. Kind of annoying there. This button does nothing. Not sure why that doesn't do anything, but if you want to do anything else, like say move the traces, you got to hit this button and then this button, select the channel, and then the gain. Nope, not the gain. You want to change to the position, and now I can move channel 1, so we'll get confusing and put channel 1 below channel 2. All right, so there is a view of the signal. This can handle up to 20 volts peak to peak. And for frequency, well, bandwidth is in theory 200 kilohertz. So let's give that a test. Let's first crank the amplitude up a little bit more to 2 volts. And we'll be looking for it to drop down to 1.4 volts. 1 kilohertz. There's 10 kilohertz. So you can see already one of the problems, it aliases pretty badly. So we're at 50 kilohertz and already we've clearly aliased back around. We've got to get back to nothing on the screen to get to time-based mode. Sorry, so we're zooming back in there. Now let's keep going. 110, 170, 180, 190, yep. And so there we are. If you look up here, we're at 640 millivolts per division. And that is indeed the 3 dB bandwidth right there at 200 kilohertz. So minimum time base resolution is 8 microseconds per division. Kind of annoyingly, it switches over from powers of 2 to multiples of 2, 5, and 10 at higher intervals. So, yep, there we go. So 128, 256 microseconds. Now that's 500 microseconds, and now from here on, we're at 1, 2, and 5, the standard sequence. The gain also, it's actually pretty hard to read what exactly the amplitude of the signal you're looking at is on the screen. I'm going to turn off channel 2 here just because it's kind of annoying. All right, so we're going to crank up the gain. Oh, nope, sorry, can't actually do that. 640 millivolts per division, that's as much as we go. Oh, no, my bad. Wrong channel. All right, there we go. Again, highly modal interface. Rather confusing as a result. Okay, now we're actually seeing what we thought we should have been seeing. One feature of this oscilloscope watch is that it can, in fact, show FFTs. I know everybody loves FFTs, so let's take a look at what the oscilloscope watch's FFT looks like. All right. Yeah, there we go. So, you know, not too bad. You can see that we have a tone that looks like it's at about, 200 kilohertz. Nothing's really labeled here. All you can see up at the very top here is that we're at 1 megahertz max, so the far right side is 1 megahertz. So 0 is always on the left. You can't change that at all as far as I can tell. And then we have a tone there at 200 kilohertz. Yeah, reasonably clean. If we go in and change the waveform to a square wave, you can see the expected third harmonic show up and a couple other ones. So there's the third harmonic at 600 kilohertz. And you can see the other one at 1 megahertz, the fifth harmonic. Yeah, kind of uselessly, you can change the FFT window, and I don't know why you'd want to on the screen this small when nothing else is labeled, but you can go up to rectangular if you want, or just go back to the default of hamming. Before we leave scope mode, I want to see one more thing. Well, let's look at both the channels again. So turn channel 2 back on here, and we'll change the gain to match. Scope XY mode. So there you go. You can, in fact, look at signal constellations. Very, very tiny signal constellations, especially if you pump up the gain a little bit. Yeah, that's kind of neat, right? All right, so I know what you're thinking. I know you're thinking, that's great if I want to look at signals, but what if I want to generate signals? Well, you can do that. So all you need to do is plug in a few more cables here. So if you go into the third pin, that's the ArbGen output, and right next to it is another ground. So we'll just plug in there. And then we'll hook it up to our scope. I'm going to actually leave the input from the other ArbGen, from the big lab ArbGen going, because it turns out that the adjustments to the ArbGen on the watch occur only on trigger events for the scope, which is kind of weird. And as a result, the UI gets really slow and unresponsive in ArbGen mode unless you have a signal coming into the scope. So that's why I'm going to leave that on here. But if you go in and go to ArbGen mode, you can choose different wave types. You can go, we got a square wave, you can go to sine wave, triangle wave, exponentials, noise, sort of, or more or less. You can even do custom waveforms, like a true ArbGen, except for, turns out that I can't get the USB port to work. It won't connect to my computer, it won't connect to any of my computers. So that's a bit of a bummer. It works to charge the watch, but I can't get it to actually pass any data, so that's too bad. I do want to say also, as I'm futzing with all this, I have mad respect for Gabe, the guy who designed and built this watch. I mean, yeah, it took over 10 years to actually deliver it, but he actually delivered it eventually, which is more than a lot of people do. He just fell into the trap of hardware taking far more time and, more importantly, far more money to see to fruition than anybody expects. But again, mad props to Gabe. So let's try just a normal square wave. And let's go in here to frequency. All right, so the frequency controls, not great. You can kind of see the current frequency over here on the left. It's right now we're at 10 kilohertz. We can increase that. We can increase that all the way up. There's a low pass filter at 53 kilohertz, but you can keep going quite a lot higher. We're at 125 kilohertz. That's the max. You can see our peak voltage, peak to peak voltage at 125 kilohertz is just 3.3 volts. So pretty far down from the 8 volts peak to peak we were at before. But it is still putting out basically a sine wave. Something that I actually used this for the other week was generating a PWM. It was basically for a servo controller that was going into a race car. And long story short, I almost needed this to generate that signal. Ended up, didn't actually use it, but man, I came so close to actually using this for some practical application. I was very thrilled. Duty cycle. See, now that's really the key to the ability to use it as a PWM generator. So you can see you can go that way and go the other way. PWM. So I did want to point out one other ArbGen feature here, just to show the bandwidth that it can generate. Right now I have it on a minimum pulse width effectively in square wave mode with the duty cycle set way down. Pretty decent spectral content, at least, out to 100 kilohertz or so. It really starts falling off after that. Not surprising based on what we had seen before. Okay, so I know what you're thinking. You're thinking, well, this is all great, but what I really want to do with my oscilloscope watch is play games on it. Look at that. Games. You got Snake, Pong, chess. Yes, Snake, the old Nokia phone classic. Being the little snake. A lot of the menus don't actually work. Load doesn't work, save doesn't work in the oscilloscope page. Config doesn't work on the settings page. Some of the buttons don't seem to do much of anything, like this one, while other buttons are so severely overloaded and modal that it's hard to keep track of what does what when. All right, logic analyzer. I'll be frank, the logic analyzer, I didn't really test it because it's really difficult to use. The idea anyway is that you would put your signals here for the logic analyzer mode into the bottom. You know, you got pin all the way on the left, that's ground of course, but then the first two pins after that are for I squared C, and then after that you've got UART, and then after that you got SPI and some other things. So you can use all of the pins in a parallel decoding mode, but you can in fact see them on the screen. But unfortunately, again, I just found it very difficult to use and really kind of just punted on it. Sorry. So the screen's one thing I wanted to mention. It's actually a very crisp, visible screen upon which you can read text fairly easily, even this very, very small font. However, when it's dim or dark out, it is really, really hard to see this screen. There is nominally a backlight, but quite frankly, it doesn't work very well. So again, I don't want to be too hard on Gabe. He did, in fact, design and build an oscilloscope watch. It does do most of the things that it claims it should do. And he did, in fact, ship it. It took him 10 years, but he did ship it. So despite the sort of, let's not mince words, crappy 3D printed case, and the sort of baffling UI decisions that were made, it's not bad. It's not bad. It's a novelty. My friends got a kick out of it, my geeky friends. And so there you have it, oscilloscope watch.